Good morning or good afternoon, and welcome everyone. It is my pleasure to be your moderator today in this session on sargassum. Your presence in this session suggests that you are aware that pelagic sargassum is a brown macroalgae abundant in the Sargasso Sea of the North Atlantic and the Gulf of Mexico. Since 2011, coastal areas in the Caribbean and tropical West Africa began to experience extraordinary beach inundation of sargassum. This emergent issue has been the subject of active research as well as policy development to guide response. While we know a great deal more now than we did when the first influx occurred in 2011, there are still questions to be answered. To address this subject today, we have a diverse panel with representation from across the Atlantic, both North and South America, as well as the West Coast of Africa. We have an hour and 20 minutes together with 4 presentations, approximately 10 to 12 minutes each, following which we will have time for questions and discussion. Audience members, please send us your questions via the chat box you should see on your screen. We will hold questions for the Q&A period at the end, but you can send your questions at any time. Preliminaries out of the way, with no further ado, I am pleased to introduce our first panelist. Frank-Muller-Karger is a professor in the College of Marine Science at the University of South Florida. He is a biological oceanographer who conducts research on marine primary production and biodiversity by combining traditional oceanographic methods, satellite remote sensing, and large data sets. He has fostered significant international collaborations to better understand life in the sea. He co-chairs the Marine Biodiversity Observation Network, or MBON. Frank invites all of you to help advance the integration of biological observations in the Global Observation System, or GOOS, and I'll drop a link in the chat for you. Frank will be presenting on the establishment of a sargassum population in the tropical Atlantic as a biological consequence of a basin-scale long-distance dispersal event. An extreme wind anomaly in 2009 to 2010 marked a tipping point that caused important ocean-scale ecosystem changes with significant recurrent social and economic consequences as territories in the Caribbean Sea and tropical Atlantic Ocean experience annual influxes of sargassum on their shores. Frank, the floor is yours.
Thank you. Please confirm that you can hear me and that, that you can see the screen. Great. Thank you, Karima, and welcome everybody. I'm going to summarize a paper that we published not too long ago that is published in Progress in Oceanography. And I know that you can't copy down the link too quickly. I'll try to paste it into the chat later on, but basically it's Progress in Oceanography. The first author is Libby Johns. And if you look for sargassum, you'll find it. So there's a number of authors that participated in this and put a number of technologies together to try to understand the event that we have. So I'll briefly talk about the background, the case for how sargassum arrived into the tropical Atlantic in the 2009-2010 timeframe and why it is recurring, and then some suggestions for research. So the arrival of the sargassum in the tropical Atlantic, by that I mean close to the equator in the Atlantic, was kind of discovered by Jim Gower, and he was looking to explain where and how the sargassum in the North Atlantic and the Sargassum Sea varied from one year to the other. And so he was kind of focusing on the Gulf of Mexico. But then as he looked at the time series and published this in 2013, in this paper listed here below, so that there was a big accumulation across the Atlantic in 2011. Now, with Chuanmin Hu's and Meng-Kyo Wang's effort, there's much better information about this, how and where this occurs, and they have this SAWS advisory program that many people are now looking at, and it's also distributed through the Sargassum. So Chuanmin is going to talk about that next. So the 2009-2010 winter was anomalous. We know that there's many published reports of anomalous temperatures, winds, currents, many different biological anomalies throughout the North Atlantic and Europe and the USA during that 2009-2010 winter. So one of the ways that people characterize that event is this index that they call the North Atlantic Oscillation, or NAO. 2009, 2010, that winter had a very, very, very extreme negative NAO compared to anything that we had seen in the past. And what that did is that if you look at the winds here on the right, and I'm going to breeze through this, normally you have winds that we call the westerlies that flow or blow from west to east. And those winds during that winter were a little bit stronger and farther to the south, basically kind of in the middle of the Sargasso Sea. And so that winter, what we have tracked with up to about 5 different lines of evidence in that paper is that the Sargassum that normally accumulates in the Sargasso Sea was blown out of the Sargasso Sea toward the east, toward Europe, and got caught in the Canary Current and flowed south along the coast of Africa toward the tropics, toward the tropical Atlantic. So that's how it arrived into the area of what we call the North Atlantic Current, from where it then flowed or got blown directly into the Caribbean or further south along the coast of Africa into the Gulf of Guinea and closer to the equator. So that's this big red arrow that I have drawn in there. Now, that is how this is a very simple way to explain how we think that the Sargassum got from the North Atlantic to the tropical Atlantic. Now, what has been happening is that this event occurs over and over almost every year, not every year. There's some years like 2013 where the accumulation in the tropical Atlantic did not occur as strong as in other years. And in 2016, it was delayed and also was smaller. So here's a representation of the type of data that Chuanmin Hu and Menkyu Wang produced, the colorful concentrations of Sargassum. And what we've done is overlaid the outline, or that black line is kind of the trace of the intertropical convergence zone. So if you look at the middle panel, kind of May, June, July, August, if you look at the top one, you'll see that the intertropical convergence zone that looks here like a line, it's really a very broad band of strong winds that converge along into that line. And so it's like a 300 to 400 kilometer wide band of strong winds. That actually moves toward the north with the seasons as the sun shines further north in the Atlantic. So if you see the line moving north and all the way throughout August, you'll see that the Sargassum bands moves with it. So the winds are moving the Sargassum into the band, and along in the band of Sargassum moves north with the ITCZ as it moves north. If you look at the next column, September, October, November, as the ITCZ starts going back south, basically as we start switching back into the northern fall and winter, the Sargassum is left behind. You see the line of high density Sargassum is left behind as the ITCZ moves back toward the equator. And if you go back to the beginning of the year, the first column here, you see that concentration, the year's remnant population gets blown toward the south as the winds intensify and the ITCZ strengthens again in this very close to the equator. So the Sargassum that was kind of left in the around 10 degrees north gets blown back south, and those patches reaggregate, and the whole cycle recurs. So that's kind of the way we think the bloom recurs every year. And the way that we think intensifies is that the same very strong winds lead to a mixing of nutrients from deeper waters. And you can see that in nutrient profiles in the World Ocean Atlas. You can see that in numerical models and look at the mixed layer and nutrient concentrations. There's an enormous amount of nutrients mixed into the upper water column that we think is effectively providing nutrients for the bloom underneath the ITCZ and into this Sargassum belt. So you see that some years, like here in July 2013, there's no band, and in July 2016, the band is lower. And so this helped us come up with a hypothesis where we think, and we looked at the mixed layer depth in the tropical Atlantic, when the years where we had higher mixed layer depth, and here the mixed layer depth is shown in blue, the blue line, you see that the Sargassum concentration goes kind of up and down with the depth of the mixed layer, and this mixed layer is around 4 degrees north. So the higher or the deeper the mixed layer, the more sargassum, the shallower the mixed layer, the less sargassum. So if you look at 2013 and 2016, those were years where the winds were weaker and the mixed layer depth was shallower. So there's not as much nutrient provided to the overlying sargassum belt. Anyway, so this is the hypothesis that we had. That's what happens in the yellow band, kind of at about 5 degrees north. And then all that you see happening in the along West Africa and in the Caribbean is that the currents and the wind blow this band into this region, and you end up with a material on the coast. So what we would like to propose as a research idea is to go test this idea of vertical mixing due to eddy turbulence, wind mixing, Ekman pumping associated with strong winds in the ITCZ, and changing surface thermocline structure in the Atlantic, which is extremely dynamic. And compare that to other hypotheses, like people have suggested maybe there's an influence by river inputs, the Amazon River and the rivers in Africa, which are actually quite far away from the area of the initial aggregation of the bloom. Then we also need to combine this with research on ecosystems and people, and what happens in the surface and coastal ocean, and also in the deep ocean. We have, like in this lower left-hand corner, there's evidence that the sargassum around underneath this sargassum belt falls all the way to the bottom to almost 3,000, 4,000, 5,000 meters depth. So this can have an impact on bottom communities. So thank you. That's the presentation.
Thank you, Frank, for that very informative presentation. I found that very interesting. I especially like that correlation with the quantity of sargassum and the depth of the mixing there. That was new for me. Audience, we encourage you to submit your questions again via the chat for Q&A at the end. Following from Frank's presentation on what the underlying causes that are bringing us these sargassum influxes in the Caribbean and tropical Atlantic, our next panelist will be speaking on forecasting these influxes, as was foreshadowed by Frank in his presentation. Chuanmin Hu is currently a professor of optical oceanography at the University of South Florida. He uses laboratory, field, and remote sensing techniques to study marine algal blooms, oil spills, coastal and inland water quality, and global changes. His research has led to the establishment of a virtual antenna system to generate and distribute customized data products in near real time, from which unique coastal observing systems have been developed to address specific monitoring and research needs. Chuanmin will be presenting to us today on a simple tool to forecast short-term sargassum movement, the Sargassum Watch System, or SAWS, that generates custom near real-time satellite imagery to monitor and track large sargassum mats and provides inputs to sargassum outlook bulletins for various stakeholders. Chuanmin, the floor is yours.
Well, thank you. Let me see if I can share my screen. Do you see my screen? Okay. Well, first, thanks for the opportunity to present this work we have been doing in the past few years. Actually, this is a PowerPoint I prepared several months ago. I just revised a few slides. So for that, I think most audience is already aware of the problem, especially after Frank's talk. So I'm gonna flip through the first few slides very quickly, okay? What is the sargassum? Everybody knows. It can be good, it can be bad. Where is the sargassum? I'm not sure if everyone knows this, but there is an organization called the Sea Education Association. in the past 20 or 30 years, all they have been doing is they have this dedicated boat to sample sargassum in the South Atlantic Bight. Okay, every season they sample a specific region, then they compose all the information to generate a large picture. And this is for about 13, 14 years composite. And from this, you can see where the sargassum is. Of course, most sargassum is in the Sargasso Sea, okay? And recently, Frank showed this with Jim Gower's work. We found this recurrent sargassum belt across the Atlantic. And the belt started to form in 2011, and it occurred almost every year except 2013. In this graph, we don't have anything after 2018, but in the past 2 years, the belt repeated at about the same magnitude. Okay? So talking about the recent sargassum phenomenon, we have two things, okay, to ask. One is about the knowledge, why? The other is the capacity, what we can do now, okay? On the knowledge, Frank explained it very well. It's plausible. It's a long distance dispersal from the Sargasso Sea to the tropical Atlantic during 2010 and 2011, which brings new seed population to this tropical environment. And then in individual years, different oceanographic processes modulate the abundance of sargassum. And there are many factors beyond physical oceanography. For example, the atmospheric deposition of dust, and at local scale, the riverine nutrient input. Those are in addition to the oceanographic, the ocean mixing or upwelling processes. I totally agree. This is still an active research area. In general, sargassum has been understudied in the past decades. Hopefully, this new phenomenon will stimulate more research to have more knowledge to understand why. At the same time, we have built some capacity to monitor, track, and forecast sargassum. Okay, that's our current capacity. So how exactly do we do this? We combine field, lab, and satellite remote sensing measurements to form an observing and forecasting system. First, we have to go to the field and relate the biomass or cover density or biomass density to the color of the surface. Explicitly, that is spectral reflectance. So we have an instrument to relate the sargassum biomass density to reflectance. Then we expand this knowledge to satellites because the satellite measures the color of every location every day. So this is a picture from a satellite. MODE is a satellite. You see cloud-free ocean. This is around the Yucatan Peninsula. Okay, you see clouds, you see land. But other than that, you see very little. But we have tricks to remove all this surface information to extract the sargassum information to come up with this type of image. What you see is the blue ocean overlaid with some slicks, greenish color. Those slicks have a very unique spectral reflectance that we can identify as a sargassum, okay? But the problem is the cloud and also other artifacts. You don't have this data everywhere. So we put several days of images together to remove the data gap to come up with a relatively cloud-free image to show the sargassum distribution and also abundance. The color shades means abundance, okay? And more than this, we overlay the surface currents derived from other groups. So this is the same image overlaid with the surface currents. So by combining the two, anybody can come up with a very short-term forecast because you know where this is and where is it moving, right? So we have this type of tool for many regions across the Caribbean, the West Atlantic, East Atlantic, and the Gulf of Mexico. So for every region, we have this capacity, and we call this a Sargassum watch system with a web link provided here. And in every region, you have a weekly composite image like to the right, for the Gulf of Mexico. So you can interpret the image. So you have this a clickable map to select a region of interest. You can select any region and browse the image. And on the website, you can also animate a sequence of images to visualize the movement of Sargassum slicks. Okay? And based on this, you can form your own local, a simple forecast system. You know where Sargassum is, you know the surface currents, and you can form a short-term forecast. And this is exactly what people did back in 3 years ago. So they used the online system combined with and their own interpretation. They forecast what will happen in the next 2 or 3 days to this island, to that island, with some validation from helicopters. Okay? And the same idea can be used to forecast a general outlook for a larger region, for example, the Eastern Caribbean. Okay, so every month we can forecast for the next 2 or 3 months what will happen in this region. The accuracy is about 60 to 80% for the Eastern Caribbean. For the Western Caribbean, because it's a longer distance from the Atlantic, tropical Atlantic, the accuracy is much lower. But at least we can predict a general outlook. So based on this idea, every month we generate a Sargassum outlook bulletin to show what is going on in this current month and what may be going on in the next 2 or 3 months for the Caribbean and for the Gulf of Mexico. We have been doing this for the past 2.5 years. Every month we send out this bulletin, okay? So it looks pretty nice, right? But we have a lot of limitations, okay? And the source cannot do everything, okay? It's limited by several factors. For example, it cannot have automatic short-term prediction. You have to rely on human interpretation, okay? You need to have a human specialist. And can't predict the far future. This is because we do not fully understand what drives Sargassum blooms, okay? So we can't predict what will happen next year from now, okay? Then we cannot provide daily updates everywhere because we have clouds on the sunglint. So every few days we can fill gaps, okay? But even though after we fill the gaps, we still have a lot of data gaps near the shore, near shore waters within 30 kilometer within the shoreline. The reason is we don't have a very good algorithm to interpret automatically what's going on in every location from the MODIS, VIRS, coarse satellite images. So rather than putting out the false information, we put a mask, we put no information. And here is an image pair to show what I meant. You see this weekly composite to the left, that shows the Sargassum distribution, but within 30 kilometers of a shoreline, that's outlined by this red outline, there's no data, there's a gap, okay? That's because of the problem I just mentioned. What we can do to fill this gap is to use higher resolution data from Sentinel-2, Sentinel-3, or commercial sensors like a Dove or WorldView to fill this gap. And what we also need is the algorithm to extract Sargassum features from this high resolution imagery, which is much more difficult than working on coarse resolution imagery. But we have made progress. We have not implemented the algorithm yet. We are still testing, but that's the to-do list, the priority to-do list on our schedule. Okay, so here's a short summary on what we know about Sargassum and what capacity we have currently. Sargassum blooms and inundations have increased. Perhaps you know this already. We have this recurrent Sargassum belt. And Sargassum inundation in the Caribbean and Florida all are connected to this gasp, this Sargassum belt. It's not a local problem, but it's connected to the tropical Atlantic. So we have developed this source to monitor, track, and forecast blooms and inundations. But source is limited in several aspects. Although we have some solutions, we still need to implement those. Beyond this, we need to have a sustainable support to keep what we are doing right now. More research is required to better understand Sargassum bloom. This is in line with what Frank just said. Sargassum is understudied. We definitely need more research. With this, I want to thank you and wait for questions.
Thank you, Chuanmin. Most interesting. It was very interesting for me to see how the mechanics of how these forecasts and predictions are made to get to the bulletins that we look at here in the Eastern Caribbean. So excellent, thank you. Audience, again, I'm just encouraging you to continue to submit your questions via the chat for our Q&A session at the end. From here, we are going to move across the Atlantic to our colleagues in West Africa. Kudjawu works with the Environmental Protection Agency in Ghana. She's the acting director with the Natural Resources Department. She's a natural scientist with interests in biodiversity conservation, water resources management, invasive species management, and environmental impact assessment. She successfully coordinated the African Development Bank's sponsored Integrated Management of Invasive Aquatic Weeds project and led a team to carry out a study on the occurrence and impact of sargassum in the west coast of Ghana. She also led the development of an invasive species strategy and action plan for Ghana and was involved in the preparation of an invasive species strategy for the Abidjan Convention. She currently coordinates the invasive species program and is responsible for ensuring the functioning of the technical working group on invasive species hosted by the agency. Jewel will be speaking to us today on the occurrence and impact of sargassum in coastal waters of Ghana. Over to you, Jewel.
Thank you. Good morning, good afternoon, good evening. Let me try and see what I can share my screen. But I apologize, my network is not strong, so I wouldn't want to use the video. Okay. Please, can you see my screen? Hello?
Yes, yes.
Okay. So this evening, I'll be speaking on the occurrence and impact of sargassum in the coastal waters of Ghana. I will skip the outline, and to introduce the subject, I have Ghana on the left-hand side of the screen, and the population of Ghana is about 28 million. We have a land take of about 24,390 km squared. We have 4 coastal districts. Our coastal area stretches at 550 kilometers square. The coastal region is densely populated. We have about 40% of people living in the coastal stretch. And we all know the amenities and what the coastal district provides for our communities. For sargassum species, since 1960, we have had 2 main sargassum species in Ghana. The first is the Sargassum vulgare and then Sargassum filipendula. And the vulgare is found usually growing attached to inshore rocks. And we have the filipendula also usually growing attached on underwater offshore reefs. But these species have not been invasive and they are still not invasive as I speak. However, since 2009, we saw invasive seaweed sargassum arriving at the shores of Ghana. But in 2011, the beaching increased. We had huge volumes arriving on our shores, and we had significant fouling in the western parts of Ghana. And this caused a lot of issues for those in that area. In 2014, we had an upsurge. Hitherto, it was only on the western coast of Ghana, but in 2014, all the 550-kilometer stretch of our coast had Sargassum arrivals. To date, we still have Sargassum occurring. It's cyclical in nature, but the volumes have reduced as I speak. And so when the Sargassum arrived, we undertook some management activities. And the first we did was to clean up our beaches. That is the stopgap measure. And what we did was to mobilize communities to clean the weeds. We provided them with simple handheld tools to clear the weeds. The government also contracted a waste management company called GEO to also clear certain portions of the weeds. But at a point, the communities, they became apathetic because of the huge volumes of weeds that was arriving. There was also inadequate equipment, because we all know that for such activity to be undertaken, we need heavy equipment to cut the weeds to a disposal site. Getting a disposal site to also dispose of the weeds became a problem. At a point, we had to dig a huge hole to deposit all these weeds inside. There was also effective coordination within the district assemblies, because the weeds cut across 4 districts, they all had to come together to plan of how to clear the beachfront, and it became a problem. So it got to a point, everything was left on the beaches untouched. And the sheer volumes that continuously arrived at the beaches made everybody to give up and to leave the Sargassum on the beaches. You can see on the screen, the middle part is some parts of the beach that we had the Sargassum arriving. We also were tasked to find out the possibility of using the Sargassum weed. And so some research was conducted, and we wanted to use it as compost. But it got to a point, those who were doing it, because of the shell and salt, the salt in the Sargassum, they also gave up that research. But we also wanted to find out whether we could have an industry to do the processing of this as feed for animals. But the uncertainty on the weeds that are arriving made people to give up, because we don't know whether if you build an industry around it, it will survive, or at a point in time, the weeds will not come again and then it will collapse. Our researchers also did investigation and found out that some of the Sargassum arriving had traces of heavy metals. And so that also became a problem for us. The agency I worked with also commissioned a study in 2015, and the study was to identify the species causing the problem, the coverage, the use, and its ecological and socioeconomic impacts. For that research or study, what we did was just to develop a questionnaire, which we administered in 36 coastal districts in Ghana. And we had about 80 men and 80% men and 20% women responding to the questionnaire. We also used the morphological features to identify the weeds that was arriving on our beaches. And the findings show that the weeds that arrived here are the Sargassum natans and Sargassum flutans. And we all know from literature that it comes from the Sargasso Sea. We also, based on the study, noted that it was affecting the Caribbean, Central America, and West Africa. So Ghana was not the only country experiencing the influx of sargassum on our beaches. In respect of its impacts, it was affecting fishing, we all know, tourism, beach access, and the worst part of tourism is that it made the whole area rot because when it arrives, it emits a pungent smell, and this made guests not to come to the hotels. It also had human health impacts in terms of it itches people when they go close to it, and all our sensitive coastal habitats were all affected. Based on the findings, Ghana wrote to the Abidjan Convention to support us to find a way of addressing the problem, because we noted that local action alone will not be able to address the problem. And when we wrote to the Abidjan Convention, we had other countries also writing to them to support us. So based on this, in 2015, 9 West African countries met in Sierra Leone to discuss the issue at stake, to share ideas, and then to find out ways of promoting its use, and also the best practices that people have used to address the challenge in their countries. And this meeting and subsequent meetings led to the development of a regional strategy for invasive species management for Ghana. Key issues that we addressed in the strategy was the need for manual removal where possible, the need to promote its use, and to develop an early warning system. And I'm happy that research is now able to forecast, like Dr. Hu said just now, they have something that we can use to forecast the coming of the weeds. Ghana has also developed an invasive species strategy and action plan, and this is to ensure that we have a coordinated way of addressing invasive species. The invasive species is not only the marine environment that is affecting, it's affecting both terrestrial and inland waters. And so this strategy is to help us to manage all the species that we have in Ghana. Currently, we also have a project running, and the title of the project is long, but the short form is SATRAC. And this is a collaboration between UK, Ghana, Barbados, and some and Jamaica universities. And the project is to improve the prediction of Sargassum events, to monitor and risk map Sargassum events, to assess long-term use and local demand for Sargassum products, and to explore regional Sargassum governance and management options and issues. And so I think at the end of this project, it started in 2019, it will end in 2022. And I hope that when it ends, it will go to support the various research work that is being undertaken all over the world. In conclusion, I will say that Sargassum seaweed menace is plaguing many countries, and Ghana is not the only one. The question I keep asking myself, whether it's a potential new normal, whether this will continue or it will stop at a point in time. And I'm happy that a lot of scientists are researching into this, because we need to understand the science behind this Sargassum, whether it's a result of nutrient loading, whether it's a result of ocean circulation, as a result of climate change. I think we are having some pointers to this based on the two presentations we have had. And so I am happy that we are researching into this menace that is plaguing us now. We also have to do active research in its utilization. And for this, a lot of questions have been raised. And the key question is whether this thing will continue or it will stop. For this, the scientists are the best people to tell us whether we should have an industry around it, or it is not needed, because you cannot put an industry and then at the end of the day, the Sargassum will not arrive again. In West Africa, a lot of research is being conducted, some for its use as pharmaceutical, as feed, as compost and the like. And I hope that in the near future, we will arrive at a conclusion to support our work. We also have to implement adaptive strategies. Now, a lot of our beaches are fouled with Sargassum. What do we do now? I think one of it is for us to learn to share experiences so that we will adapt to how people are managing the situation in their various countries. And last of all, it's important for us to mobilize international support to address this global phenomenon. And I'm happy that this is one of the forums that is being held to bring the international community to the notice that such a situation is happening, so that they support countries that are being impacted by the Sargassum menace. So with this, I thank you for your attention.
Thank you, Jewel. I thought that was an excellent job outlining for us the management and adaptation challenges that these Sargassum influxes have been bringing, especially to developing countries on the west coast of Africa and small island developing states like my own in the Caribbean. I fully support your comment on international cooperation and the need for that to address some of these transnational and global issues that are impacting us. So thank you again for that. Audience, once again, I'm going to go ahead and encourage you. Please keep the questions coming via the chat for our Q&A at the end. Moving along, as Jewel highlighted for us, Sargassum influxes are an adaptation challenge. But our next speaker comes at this problem from a different perspective. Paulo Horta is an associate professor at the Federal University of Santa Catarina in Florianópolis in the south of Brazil. I'm sure he'll correct me on my pronunciation of that. He works in undergraduate and graduate programs on biodiversity in botany, ecology, and oceanography, teaching and supervising in the areas of marine ecology, ecophysiology, and macroecology. He is currently engaged in evaluation of climate change and marine pollution impacts on marine forests and ecophysiological processes in key organisms. Using various analytical tools and approaches, his research takes a broad perspective to foster transnational actions regarding marine conservation and coastal management. Paulo will speak to us on Sargassum from a different perspective, given the large quantities of biomass, not as a problem, but as a potential natural carbon sink with potential role in climate change mitigation. Paulo, over to you.
Okay, thank you very much for this opportunity to share what we are doing here in Brazil regarding this subject. And well, I think it's time to learn a bit with this pandemic and think different, think without the box. And this is maybe, of course, a huge problem, but that can be seen in a different perspective. This is what about my presentation here. Well, our experience in Sargassum question or problem is related with our group of monitoring program in Brazilian coast. We have something around 10, 20 institutions around the coast working together, fixing things, working, well, trying to build some structure. And all these people in 19, well, after the beginning of this century, we start to identify Sargassum floating in our coast, especially in 2012. Well, after that, we start a taxonomic study and all different kinds of studies. All of them I will put for you. But what is interesting is Sargassum was arriving our coast. And after that, we start to discuss, okay, if it happen again, what we gonna do? Well, the amount was more or less as observed in Ghana. So we had once, and the next year we didn't. So that was a problem. Wow, how can we use it if we have no certainty about regularity of this process? Well, what we observed is that our beach in the north of Brazil, close to the Amazon mouth, plenty of Sargassum. And also some MPAs, marine protected areas, very important to us, as Fernando de Noronha Island. It's a very beautiful tropical island, oceanic one, so very delicate ecosystem. So yeah, some small scale of what is happening in the Caribbean for the last 10 years, so at least. So, well, look into this question, or to this problem again. My student, Lidiane Gouveia, start an alternative perspective, trying to, well, something that was worked or discussed already in this last 10 years. But for this first time, we did a model of this bloom. And we observed that all this biomass that, of course, are absorbing carbon dioxide and, of course, producing when floating, when in the surface, producing a lot of oxygen, can be used in some proposals like climate change mitigation. Once our models reveal that we can have a lot of biomass in these systems, as we have in the models presented and in the satellite images we saw in the previous presentations. Well, we have a huge extension of Sargassum around the Atlantic, from the Africa to the Caribbean. And as we can see in this table, here in the bottom of your screen, we see that the area covered by Sargassum is bigger, is huge, bigger than mangroves, bigger than salt marshes or seagrass. Very important vegetation systems or forest systems that can sink CO2, and for that they are known as blue carbon environment. So starting from this point, we look for the above ground biomass, the biomass that we have in Sargassum and the biomass we have in mangroves, salt marshes, and seagrasses. And as we can see here, the amount is equivalent, or in some cases higher. So why not look for this opportunity? So for that, we saw the carbon content, and again, the amount of carbon is higher than the amount of carbon observed in mangroves and salt marshes and seagrasses around the world. I'm talking about the floating Sargassum and the benthic one. When we combine these two strategies of niche occupation, well, we have this amount that we look as something important to the humanity. This is our perspective. Well, what is interesting is that our model present a very similar image that was observed in the satellites. So analysis, adding information about the benthic composition and the abundance. When we look for the factors that explain the distribution of niche suitability and abundance, we will see for the niche suitability and to the distribution model, the iron, the phosphate and nitrate appearing as major factors or major drivers of this suitability. In other words, we are talking about nutrients to the seaweeds. When we look to the biomass model, then the importance of nitrate and phosphate and iron as fertilizers, the importance is higher. So starting from this point, we can draw some likely scenarios and look into what happened in Brazil since 2010 is something that should be bring to our audience. Once we observed since then higher mining activity regarding iron, especially iron, and deforestation to agriculture proposals. Of course, we are talking about Amazon, but we need to take in consideration the Tocantins River, where we have a huge agricultural activity and mining to activity, considering gold, iron, and other metals. So if you put all that in our melting pot here, we can see that the land use, we are changing it, and we have very, very strong evidences that this land use is changing the potential growth rates that we have in our Sargassum Sea, and of course all the consequences we have to the environment, ecology, and maybe evolution. So we must take care about it. We are talking about a lot of different factors, but I think we did introduce with some highlights the CO2, because this is a very important resource to the primary producers like Sargassum. So this is something that we must take care from now, and we are trying to include in our experiments and models. Well, management emissions in land, I'm talking about mining, deforestation, and of course agricultural changes we are producing in our lands are changing the continental runoff, and changing it, we are changing the plume quality of all these big rivers and our coastlines, transforming our Atlantic in a kind of bioreactor, where the Sargassum that was displaced to the South Atlantic or to this equatorial area are growing much faster, doing all these factors together. It's a very complex scenario that we should take care, and we should take care together of it, because the consequences of it is more problems. Well, this is the results of some colleagues from Caribbean, from Grenada, and what they are observing when the Sargassum is beaching is the reduced oxygen levels to zero for long periods, and pH very, very low. So we are producing locally ocean acidification and accelerating the losses that we are already observing, considering climate change and considering all these global stressors. So yeah, so a brief, a very, very short likely scenario. So global stressors can be and should be discussed inside our scenario, as well the local stressors, considering what we are observing in South America, but also what we are observing around the Atlantic. I'm talking about Congo, why not? And Mississippi, why not? Everybody are providing a bit of participation in this bioreactor, giant bioreactor that we are talking about. This is our Atlantic right now. It's a figurative perspective of it. But yeah, if we have Sargassum blooms, it's a problematic question, of course, but in other words, can be an opportunity too, because different Sargassum can produce different molecules, different substances that can be used in agriculture through biotechnology, for example, and of course the services that these blooms produce to the ecology of the Atlantic can't be neglected. So these two different points should be taken together, because, well, if we take all the Sargassum that we have in our Atlantic, all the services, this ecological and evolutionary service will be lost. So we need maybe manage this problem considering the balance between our interests and the natural role of this process. Well, after this last 2 years, I think the problem is much bigger. I think we have really, in fact, a bomb in our hands, because the fires that we are having in Brazil this year, for example, we are burning everywhere. We are really burning our forests to produce more agriculture, etc. And well, I think the runoff should be worse, and our Atlantic bioreactor should provide, of course, likely a faster growth of Sargassum. So we need to take care, and we need solutions, and we need now. We need to change the way we are mining, producing our food, and this we can do together, linking sea and land, trying to put these two systems that we are, I don't know why, but we insist to see these different systems isolated, but they are together, they are linked. They are linked with the runoff, they are linked with the possibilities we have to use in our lands the production that we can realize in our sea, and the management, maybe using the oil exploitation infrastructure. We can use all this knowledge, all the infrastructure to mitigate the Sargassum impact and try to improve the quality of the everything and put back in our land system, trying to increase management. In other words, we need link science and management. In fact, science, I mean marine science, forest science, put agricultural science, put all together in a melting pot of opportunities, in a multilateral discussion. And for example, biorefineries that I'm talking about soon, that can be installed or introduced in Caribbean, for example, can produce the fertilizers, the new generation fertilizers that must be used in the Brazilian agriculture, for example. With this combination of uses, we will reduce the impact in both sides. We will reduce the problem of plume, Amazon plume, Tocantins plume, and we will also improve the life quality in the Caribbean using Sargassum now not more as a problem, but as a huge opportunity. I know it's a huge work to be done, but I think this is our time. The pandemic, COVID-19, is teaching us that that is possible. We can work together. The planet is working together to stop this pandemic. I think we can stop Sargassum blooms and try to manage it in our favor. Trying, for example, reduce climate change. So we have a golden opportunity. I think we do have. We just need to work together. So thanks. This is a work of a lot of colleagues from Brazil and abroad. So Marina and Ligiane was my PhD student. That most of all that was done by both of them. So thanks again.
Thank you, Paulo. That was most interesting. I love your big picture thinking. And I'm very much, as well myself, a fan of that kind of transnational, especially maybe a sort of a South-South cooperative approach to some of these challenges that we're facing. I see that we have an audience today that's a bit reticent, so we've got no questions, at least not yet. We've got about another 20 minutes in session. And so what I'm being encouraged to do is to pit my panelists against each other. Oh, I'm just kidding. But I will sort of see if we can encourage some discussion here. So one of the things I noticed from Jules' presentation is that she threw out a bit of a challenge to Chuanmin, which I thought was very interesting. it resonates with me as well. You know, there's sargassum is a problem, sargassum is a menace, sargassum is a hazard, agreed. But then we need to try to turn it on its head and make it a positive, and where are the opportunities, agreed. But you know, the feasibility of starting an industry around something where your raw material is so variable is, that's a major potential barrier to it really being an opportunity. So how can the forecasting efforts that we're seeing inform these questions of feasibility to develop an industry around sargassum? I know there's some limitations now, but is there the potential for a link there? Chuanmin, can you speak to that a little bit?
Sure. Well, thank you. Let me make sure I unmuted myself. Thank you. Actually, I was going to raise this comment to Joe. You know, after hearing the problem, you know, in the West Africa, I was aware of similar problems in West Africa. You know, I attended workshops and talked to people, but I was not aware of quasi-operational forecasting or monitoring system for the general West Africa region. You know, our source tool does cover that region, but we have no resource, you know, no energy, money, or people to focus on that region. You know, in the past, we have been focused on the Caribbean, you know, for a number of reasons. In the monthly bulletins, we only talk about the Caribbean and the Gulf of Mexico. So although the source covers West Africa, we don't put time on that. So partly because that region is more difficult to forecast. Okay, it's not just driven by physical transport, okay? And we don't, you know, fully understand what's going on in that neighborhood. So my question to Joe is, are you aware of any similar system for West Africa, for Ghana, or you know, other West Africa regions? You know,
No, nothing.
Nothing. Wow.
No.
So we may be able to extend our focus to cover that region, you know, by putting the current outlook. You know, for example, the current months, what's going on in the current months for that region, you know, have a summary. But we, when I say we, I mean my group, are reluctant to put a forecast for next month because our limit, my knowledge in that region is way below my knowledge for the Caribbean. So I don't want to put false information there, you know, before we have confidence. But for the current month, that's a nowcast or even hindcast, you know, that's much easier than forecast. So we can start from putting out the nowcast information. So what's going on this month? That is doable, but I have to consult with my own people to see how much energy is required to extend from the Caribbean to the West Africa.
Thank you very much. I think we welcome that. Sorry, I think we welcome that there is a project running in the University of Ghana in the Oceanography department. So I can link you up with Professor Piminim, and then you can start discussing on your proposal.
Right.
Thank you.
That's great. That's great. Actually, that's, I think, the right strategy. That's the right strategy. You know, the reason is, you know, the source provides a general outlook for the entire tropical Atlantic, Caribbean, Gulf of Mexico, and for each individual region, I don't think anyone has the resource energy to cover individual region to zoom in, because that's up to local people. They are the best people to work on their local property.
Yes.
Yes.
Yes, thank you. Thank you.
Sure. But we can certainly
for
provide some help, if you have, I'm sorry, that's my last.
No, it's fine. It's fine. I'm jumping in there because I may be able to help a little bit. Jewel, you mentioned the StarTrack project. So shout out to StarTrack colleagues out there. University of the West Indies, where I'm affiliated, is part of that team as well. And I do know that project has a transatlantic scope, and there is some scope within that to replicate some of the transport modeling that they're doing there initially into the Caribbean, but I know that they wanted to look at that for Ghana as well. I'm not sure the details, but that may be an opportunity as well, or maybe a point of entry for some collaboration or partnerships. So thank you guys for that, great exchange. I think it would be interesting here to explore the links with climate change a little bit more. On the one hand, we see climate change as sort of implicated in the cause of sargassum blooms, but that's not really clear to me. I've seen some references that bring climate change into the picture and others that don't seem so sure. And then we Paulo touched on us for a bit about, opportunities in terms of mitigation. So that's an interesting maybe a bit of a paradox. What are we dealing with here? Something that is a climate-driven hazard that's being exacerbated by other local stressors, or opportunity for a carbon sink that may offset other things. Anything to jump in there with, Paulo?
I think Frank has some comments.
Oh, please do.
Oh, yeah, well, thanks. I do think that there needs to be as we have said before, there needs to be some research on that question and exactly what the mechanisms are. There is this event that we saw in 2009, 2010 of an extreme negative North Atlantic oscillation, and we've seen a little bit of a weaker negative one again since then. These extremes in what we call weather are more frequent. And so this is true for local and very large regions. And so I think that there should be some study of that. I do want to go back to Paulo's big picture. And I think that there's really, really interesting elements there in terms of harvesting. And this is also what Jewel mentioned, and many people in the Caribbean, Karima, you know this very well, are trying to figure out what to do with the stuff that lands on the coast. Some other people are trying to figure out how to harvest the sargassum offshore. If there's some sustainable business there, or something that can help without harming what is an important offshore ecosystem. So what is an offshore very beneficial ecosystem for many organisms, even for fisheries. Many people that fish in the Atlantic are now using this as sargassum serves as a fish aggregation ecosystem. And so that the tuna fisheries and others are very much keen on this. But I have to say that we will not solve the problem of the blooms in the middle of the ocean by addressing the problems that we have in the forests in Africa and in the Amazon, because the blooms that are forming in the middle of the Atlantic are not caused by the nutrients that may be washing down the river or tied to the deforestation of the Amazon or the Congo forests. That's unfortunately has been propagated, and it's repeated over and over, but there's no evidence that there is any direct connection. And if you look at the satellite data and other historical data in terms of where the nutrients are that are related to these river plumes, they're not available to the areas where the sargassum aggregates in the middle of the Atlantic is just too far, and there are other nutrient sources. So once the Sargassum enters areas like the Caribbean or the Gulf of Guinea, you have more local effects of the Amazon and Orinoco rivers that could maybe have some impact on the local blooming, but I still don't think that it's nearly anything compared to the original source of nutrients in the middle of the ocean, which is related to winds, and that is related to the mixed layer depth, which also depends on temperature, which is in many ways affected by climate. So I think that we need to look at the connection of climate in a more oceanographic sense, and then see what happens in the coast and the land-ocean interactions and how it affects people. Yes, it's all connected, but not because we're gonna, decrease the deforestation or decrease the nutrient input to rivers, are we going to solve the problem of the sargassum in the middle of the ocean. So we need to be careful how we present this and look at the continuum of processes, oceanographic, land, people, and understand, well, what can we do in one area to affect another, but not assume that because we do this, immediately we're gonna mitigate sargassum in the middle of the ocean. We do have to control deforestation, fires, and indiscriminate nutrient inputs, but for other reasons, not for this reason.
Can I comment just one thing, Frank? Very nice. I agree with you in part, just because I think we can have different regions in this big Atlantic portion. Maybe some regions where we have growth, huge growth, and maybe these regions can be the Amazon mouth region, you see, the big region around it, and all these regions where we have more nutrients. Just because we did an experiment, unfortunately, we are still waiting the pandemic stop to go back to the lab and to finish it. But the Sargassum really grew very fast, something around 10-20% a day, considering some conditions of nutrients, especially iron, that we just have in this region around the mouth, and of course where the bloom is more intense. So, well, of course, it's a hypothesis, and we can't ignore it that we have upwellings, and this can also introduce more nutrients in this process, and of course the growth can be observed everywhere. But as a hypothesis to work, once we observed a very, very strong link with iron and the abundance of sargassum, I think it's something that we must work with, just to introduce new arguments in the management of these lands, and mainly in South America.
I mean, I agree that if you give nutrients and iron to sargassum, it will grow, but it doesn't mean that because you have nutrients in one place, sargassum will grow in another place. And so they're not co-located until the sargassum moves to the area of the Amazon plume. Then it is exposed to the Amazon nutrients. And so the sargassum accumulates initially in the interior of the Atlantic Ocean, some 500 to 1,000 kilometers and even further away from where the Amazon plume is. And then it drifts into the area where the Amazon plume is, but much of it is never exposed to the Amazon plume. So yes, and so we need to make sure that we understand the origin and the intensity of the blooms initially can be caused by climate factors like wind speed, the temperature of the ocean, and the stability of the water column, the amount of dust coming from Africa, which does provide plenty of iron, so there are many factors, and we need to be able to understand this well enough so that we can separate cause from effect.
Thank you, guys. That's so interesting. I'm just going to take a moment here. It would be remiss of me if I did not to give a shout out to many of my colleagues from the University of the West Indies Center for Environmental Studies and Resource Management, currently working on the project Sargassum, which is going to be addressing some of the research questions that have been raised here. So for more information, I'll just pop a link in the chat for you if you are interested. But continuing a little bit with this discussion here. So Frank, help me out a bit. I feel like, or maybe just clarify, we're saying that the Sargassum, the reason we have this new source region, this belt in the tropical Atlantic, is because there was an event that allowed the Sargassum to travel there, and the conditions were already favorable for it to bloom, as opposed to a change in the conditions that created a bloom. Does that make sense?
That's correct, yes.
Okay.
So we moved a new organism into a new area where, especially an invasive species, if you want to look at it that way. It's got plenty of sun, lots of nutrients, warm conditions, so it's going to grow faster than it grows in the Sargassum Sea. In Sargasso Sea, where you have strong winters, maybe too much wind during the winter, cold temperatures, and so it's more controlled. And if you give it too much wind, the Sargassum will sink deep enough where the little bladders that it has collapse and it sinks. And so in this area where we have now these recurrent blooms, the conditions are good. It likes it. It grows like crazy.
Excellent. All right. Well, we're minutes away from the official end of our live stream for the session. So I just want to take this moment to thank all of our participants, to thank our hosts and organizers, to the IT team that's been working really hard behind the scenes, to all of our panelists, and of course the audience. I hope that was interesting and informative for you as it was for me.